Right, I want to prove that triangles ABO and CBL are congruent. If you look at the question, ABO, this one, and CBL is that one. You need to prove that these two triangles are the same, congruent. Also, it does say in the question, ABCD, this big square over here, it does say it's a big square. It does say it's a square, and we know in a square all the corners are 90 degrees and all the sides are the same size. And there is a smaller square, right, which is right here. Smaller square, meaning all the sides are the same size and each corner is 90 degrees by default. That's what a square is. So how do I get started then? Well, I can say for this triangle here, the triangle over here, this side is the same as this side. Well, it's a square, isn't it? So for this triangle, this side is the same as this side of the other triangle. I'm talking about this triangle. I'm comparing these two triangles over here. So both these sides are the same. I can say that AB is equal to BC because these are sides of a square. Right, that's actually given to us, so we're not making things up. We're not assuming it's a square. It's actually told us. Right, it's actually told us. Right, what else can we say? They've given us an angle x, so we need to use that. Right, I can safely say that this is 90 degrees. Right, and if this is 90 degrees, this is also going to be 90 degrees because angles on a straight line add to 180 degrees. So here we've got 90 degrees, all right? So in this triangle over here, we've got 90 degrees. I'll be able to work at this angle using a bit of algebra. Remember, in any triangle, right? Any triangle, just as an example, give an example here. Say that is 90 and this is 60. I can easily work this out by doing 180 because angles in a triangle add up to 180 minus the 90 minus the 60. Right? That leaves you with 30. Right? That was just an example. But I'm going to do the same thing now using algebra because I've got an x over here. So to work at this angle over here, I've got to do 180 because angles in a triangle add to 180 minus the 90 that I've got here minus, well, there's no number here, but I've still got to minus it, minus x. That simplifies to 180 take away 90 is 90, and you got the minus x. I've collected like terms. All the numbers stick together, all the letters stick together. 180 take away 90 is 90, and you got the minus x. So this one's over here. Right. This one over here, I can tell you, this is 90 degrees. All of that is 90 degrees. So to get this one, it's simply 90 minus x. Look, if you didn't understand that, let me just do an example. Say if this was a number, just say this is 60. Well, what would that be? Wouldn't you do 90 take away 60? Yeah, but instead if we've got an x over here, that would be an x. So here the green angle is 90 minus x. This one, definitely 90 because it's a square. We've already established that, yeah? So therefore this is going to be 90 as well because angles in a straight line add up to 180. Right, my job now is to work at this one. Right, I'm going to do that now. To get this angle over here, remember angles in a triangle, we've got a triangle here, is 180, angles in a triangle out to 180 minus this 90 minus this angle over here, which is 90 minus x, right, that one there. 180 take away the 90, take away this one. Need to simplify that. That's 100, well, first of all, let's get rid of the brackets. That's 180, take away 90, I'll deal with that in a moment. Minus 90, right, minus and minus makes a positive. Two negatives make a positive there, so that's positive x. So now simplify. 180 take away 90 is 90, 90 take away 90 is 0. That equates to x. So this is just angle x. So what have we established now? Right, we can say, right, you can see now the similarities there. We've established that this side is the same as this side, right? We've done that over here. We've established that this angle over here matches this angle over here. So we need to say angle OAB, which is this one, OAB is equal to LBC. LBC, right? Angle A, right, that one. Angle B, right there. That's equal to x. Both angles are equal to x. Right. What else can we say? Well, you got 90 minus x over here, and you got 90 minus x over here. They're matching as well. So we can have to say angle ABO, it's that one there, is equal to angle BCL. BCL, it's that one. You know, you can call this ABO or OBA, whichever order, but as long as B is in the middle of those two letters. So here we have, sorry, what have I written here? BCL. Okay. This is 90 minus x. So what we established here is side, angle, angle. So congruency is proved due to angle, side, angle. And here's all the working out.